So here in this slide, we have the criteria to distinguish the different sensor fusion techniques. I choose 4 main criteria, which I think is interesting for in our lecture. The first one is the target. What is the target of our algorithm? The second one is the relationship between the type of data sources. The third one is the type of input and output. And the fourth one is the type of architecture. And we will see in the next slide all these 4 criteria. So the targets. We can, based on the target, we can distinguish 3 different types of sensor fusion. The first one is state estimation, which actually, as the title suggests, is actually determining the value of a state in a given system, namely estimating the position of a car with a self-driving car example. There is then data association, but I will not give any detail about this because I don't think this is quite used in the eHealth domain, and is more used for more interesting for other type of domains such as aerospace or navigation system, but I will not deal with it. Decision fusion, this is I think the most important one. So actually, as we have seen in our example, decision fusion is when we are trying to fuse decision. An example could be combining the diagnosis of 2 different doctors. What is the final diagnosis? This is, in my opinion, the most interesting for our scope. Relationship among the data sources is the second criteria. As we can see here, we can have a sensor fusion system where the sources are complementary. So basically, and we have the first example here, we have 2 different sensors that are, in some way, sensing different part of the scene. So 2 different aspect of the object we want to measure. Differently, redundant, we have 2 different sensors that are trying to sense the same object. We can have a third setup called cooperative, where the provided information is combined into a new information which is typically more complex than the original information. So this is kind of a redundant, but where we have more complex information than before. So the third criteria is the type of input and output. As we can see, we will work with 3 main entities: data or signal, features, and decision. So we can have data in input, data in output, features in input, decision in output, or decision in input, decision in output. Architecture. So we can have a centralized architecture. So every sensor put the data in the sensor fusion system, the sensor fusion engine, and the sensor fusion engine provide an output of this. So taking the raw data from the sensor. We can decentralize architecture where, for example, every sensor unit is a kind of peer-to-peer system, take the data from the other sensor, and each sensor fusion unit elaborate its own outputs. Or we can have a distributed architecture where what we send to the fusion system, to the fusion engine, is a kind of processed information, which are not the raw data, the raw signal. What we fuse is basically not the measurement, but a kind of processed version of them. So feature, for example, or decision.
Let's try now to provide a practical declination of the criteria in the example we used before. So the sensor fusion A, the one where we fuse the video cameras and the inertial unit to get the position and then the velocity, can be seen as a state estimation techniques, which is complementary and which we have data in, so raw data in input, and feature, process data in output. The second one instead is where we use the GPS, is always a state estimation and complementary, but in this case we have feature in and feature out. Last part on this theoretical background of sensor fusion is, I think, is interesting to see what is the relationship between sensor fusion and another big hot topic of our current technology, which is artificial intelligence. So sensor fusion is included in a higher set, which is the information fusion. So in my opinion, sometimes this kind of distinction can be a bit redundant, but can be used. Information fusion and artificial intelligence, namely machine learning, actually shares, and I mean, the distinction is not defined, but is a bit blurred, because many of the techniques used in artificial intelligence are used in information fusion, and we will see some example exactly later. Basically, what the main distinction between these two areas is the fact that machine learning, for example, is based on the idea that a system can learn from the past data and it identify some pattern or correlation for future prediction. In sensor fusion, we don't have this requirement. So, I mean, the learning from past data is not something that is vital, as we will see later, for example, in the Kalman filter algorithm. But yeah, this is just to give us a bit of, topology of sensor fusion in the data science domain.